Hey there folks, Mr. G here with another educational video. This time we're going to be starting a new unit on statistics. And today we're going to be focusing on data and sampling, which are two words we'll go over a little bit more later. Now let's start with the word statistics. I'm sure you've heard that word before, mentioned on TV or maybe in some of your other math courses. Now statistics is all about collecting information. That information is what we call data. Once we have the information, we interpret it or draw conclusions, try and figure out what it means. And that's the whole goal of statistics. Now, a key step between collecting in the information and drawing conclusions, trying to figure out what the information means, is how we analyze or present the data that we have. These are the three key steps in any statistics. This week, we're going to focus on how you collect information and how to do it in an effective way, as well as what can go wrong. Next week, we'll be talking about how you can analyze and present your data. Interpreting your data and drawing conclusions can be really tricky, and this is something that gets really emphasized in Stats 12. So Statistics 12. If this is the kind of stuff that interests you, I would really encourage you to take this course when you get to upper grades. Now, each step along this process, there are potential pitfalls and traps that we can fall into that'll result in bad statistics. And this is really important because statistics are vital when we're trying to understand large amounts of data. And statistics often influence very, very important decisions, especially decisions that are made by governments or companies. I want to share a quote with you that I think is really relevant when thinking about statistics. Evan Esser said that statistics is the only science that allows different experts using the same data to draw different conclusions. It highlights that depending on how you collect your information, how you analyze and present it, it can cause you to draw very different conclusions, even if it's the same data that everyone's using. Page 283 of the workbook has many other quotes about statistics that I would encourage you to read as well. So getting these steps right is really important to getting the interpreting and drawing conclusion step right as well. Bad statistics can result in things like pseudoscience and conspiracy theories because along the way in these two steps, mistakes have been made. This week we're going to focus on collecting data, and to do that, we need to really understand the difference between a sample and a population. A population is everyone that you consider when you do some statistical study. This could be the population of a country, or a town, or even just a school. The sample is everyone you collect data from. So if your population is, say, the country of Canada, you might only be sampling a few people from a certain city. For example, a study might be thinking about all Canadians, but really only ask people from Vancouver because maybe their office is in Vancouver and it's easier that way. You might be doing a poll of Lord Byng students, but because you're in grade 9, you only ask other grade 9s. Maybe you're doing a study of Vancouverites in general, but since you live in Kitsilano, you only ask people that live in Kitsilano as well. What I want you to notice here is that depending on what sort of study you're doing, your sample and your population could end up being the same thing. So notice in one study, Vancouverites was our sample. In another study, Vancouverites was our whole population. Already you can start to imagine that if we're thinking about a study of all Canadians that only asks people from Vancouver, it probably doesn't really reflect what all Canadians think. If, for example, you did a poll about how much Canadians liked the weather, but you only asked people from Vancouver, you'd probably get a pretty different answer as compared to polling people that were only from Toronto or from Manitoba. So who you sample and who your population is really affects the kind of data that you collect and the conclusions that you draw from that data. Let's say you wanted to do a study about the percentage of students at Lord Byng that bring their lunch versus those that buy their lunch. Our population in this case is all Lord Byng students. Now when you collect your data, you have to make a choice about who you collect data from. Your first option is to do a census, which is to ask literally everyone. Now the Canadian government does a census every 5 years so that they can check on everyone in the country and get an idea of how everyone is doing. This will give you the best data because you're not worried about only asking some people, you're asking everyone. But it's really difficult and really expensive, so it's really hard to do a census in a lot of cases. Another option would be to use convenience sampling. So convenience sampling is you basically just ask whoever's around. So it could be the people in your class, the people in your grade, maybe just your friends. This is a lot easier, but it's going to give you biased data. The word bias here is really important. Biased means that it doesn't represent everyone. It doesn't represent your population. Maybe you could use this data to determine the percentage of people in your class or grade that take a lunch to school or buy a lunch, but it wouldn't represent the entire school. Another way we could collect data is voluntary sampling. An example of this would be to set up a table at lunch where students stop by and answer the poll. So people volunteer to participate. Just like convenience sampling, this is easier than a census, but it's also biased. If we're interested in the number of people that buy or bring their lunch, and you set up your table at lunch, the people that are going to buy their lunch probably aren't going to be there to answer your poll. And that's going to affect your results. It's not going to represent the whole population, only the population of people that happen to walk by your table and feel like answering a poll. Another option would be an online survey where you put a poll on the school website, but again, this is going to be biased. Only the people that go on the website and feel like filling out a poll are going to be included. And that might not really represent everyone at the school. At this point, you might be thinking, well, if we can't do these smaller samples, I guess we just have to ask everyone, but there is one good way to get a sample that doesn't result in bias. The best way to get a sample is by random sampling. So this is where we would pick 40 students, say, at random from a complete list of students and ask all 40 of them. This is unbiased because everyone has the same chance to be picked and nobody's being excluded. Now, of course, the 40 students that you pick randomly might not really represent everyone, but this is the best way to do it without having to ask everyone and perform a census. This is the best realistic way to collect data, unless of course you feel like doing a full census. If you want to make your random sample better, pick a larger number of students. 40 isn't a lot of students. If there are 1,200 students at the school, maybe you want to pick 100 or 200 instead. The more you pick, the better your sample is going to be. One thing I wanted to address is that sometimes when you look at sites with popular statistics, it's really important to see how they collect their samples. A lot of them will use one of these three. And remember that when we use these types of sampling, this doesn't represent everyone. Most times when websites quote data that aren't being taken by large sampling statistical organizations, they're really using one of these methods, and their results are probably not very trustworthy. That's the end of our first video here. Stick around for the second part where I'm going to talk a little bit more about other things that can affect how sampling goes. See you then.